Welcome back, everybody. This video is going to be about showing you how to find x-intercepts and vertices, or the vertex, given a quadratic equation. First question, what are the x-intercepts of the quadratic function f of x equals x squared plus 2x minus 24? Well, to find the x-intercept, if you were to graph it, would mean setting the function equal to 0. Which is I'm going to do here. Then I'm going to factor this, and I'm going to factor it by asking the question, what factors of negative 24 add up to positive 2? And that would be a positive 6 and a negative 4. You think about it, negative 4 times 6, negative 24, negative 4 plus 6, positive 2. Alright, so then we can set up these two little mini equations. X plus 6 equals 0, x minus 4 equals 0. X equals 6, negative 6, and x equals positive 4. So if we're to graph these on the xy plane, you can test this in Desmos too. Just know that they would cross, the parabola crosses the x-axis at the point negative 6, 0, and 4, 0. Alright, let's try again. This time I'm going to change the language a little bit. What are the zeros? Zeros, another term conceptually meaning the same as x-intercepts. So once again, I'll set this equal to 0. I'll go ahead and set up the factoring here. X and x. And we ask what factors of 32 add up to 12. And those numbers are 8 and 4. 8 times 4 is 32. 8 plus 4 is the 12. We're setting both of these equal to 0. Well, if you do that and solve, you get negative 4. And you get negative 8. And if we were to graph these, this parabola would graph, and it would touch the x-axis at negative 4, negative 8, specifically negative 4, 0, negative 8, 0, if you're naming the points. Alright, and that brings us to minimum value. Okay, minimum value, whatever this graph looks like, it opens up. I know that because of the positive x squared term. And we want the minimum value right here. That's the minimum value. We're talking about the y value. The y value of the vertex. And when given a quadratic equation in what we call standard form, you need to know what the a, b, and c are. In this case, a is 1, b is negative 18, and c is 79. So here's the formula for finding the vertex, the y value of which will tell us what the minimum value is. There's an x and y coordinate on any point, but the vertex follows this, negative b over 2a. And in this problem, g, to find the y value, we plug it back in, g of negative b over 2a. And you'll see what I mean here in a minute. So for our vertex here, negative b over 2a, negative 18 over 2 times 1. And then we're still going to figure that out here in a minute. Negative 18 is positive 18. 2 times 1 is 2. And 18 divided by 2 is 9. Okay, so the x value of the vertex is 9. But what I need to do here is find g of 9. Meaning, I'm going to put 9 into that. Into the function, that'd be 9 squared minus 18 times 9 plus 79. Alright, and 9 squared is 81, whereas 18 times 9 is 162, so we're going to have 81 minus 162 plus 79. 81 minus 162 plus 79, calculator says negative 2. And negative 2 here, let's get that written. So here's the vertex, the 9, negative 2. The value itself, the minimum value, is this negative 2. We want the y coordinate. That's the lowest value on the y-axis where this function occurs. It also is the y coordinate of the vertex. So the next question is, what's the max value? So whatever this graph looks like, it opens upside down like this, and therefore the vertex up here, whatever the y is, would be the maximum value. Alright, so we have, here's our vertex again. Remember, it's negative b over 2a. And then to find the y coordinate, in this case, f of negative b over 2a, whatever that negative b over 2a is, we plug it back in. Alright, in this problem, the A is -1, the B is 6, and the C is 11. And then negative B is -6. 2 times A is 2 times -1. Still working on what that is. -6 over -2, +3. We'll put -3 into there. -3 squared is 9, plus 6 times 3 is 18, plus 11. -9 and 18 make 9. 9 and 11 make 20. So, our y value is 20. The maximum value itself, what we're after here, is that 20 value. All right, our last question is going to address Vertex form. We got to convert from standard form to Vertex form. Now, Vertex form, so our function notation is p of x. It could be y, it could be p of x, f of x, h of x, whatever. Just a notation issue. And if in what's called vertex form, it looks like x minus h is quantity squared plus k, where our vertex in that would be h comma k. But before we get to this form, we got to convert standard. And here's how we do it. We're going to section off the first 2 terms, but we leave a space because we know we're going to need that. We have plus 29. Now, we complete the square. All we're doing here is completing the square. Completing the square, take half of the b number, half of -14. That's -7. And then you square that to get 49. And that makes a perfect square if I do plus 49. Now, normally solving equations by completing the square, you would add 49 to both sides of the equation. But no, we're actually keeping everything to one side. To offset that, I got to subtract 49 over here. The result of plus 49 and minus 49 is a net sum of 0, which doesn't change the value of the function. But by doing this x squared minus 14x plus 49, I can now factor it into this x minus 7 squared. That's the factored form. It's a perfect square trinomial. And then we have minus 20. And here is standard, or not standard, but here's vertex form. See it, x minus h quantity squared minus 20. Or in the, just the formula itself, k. So our vertex is 7 and -20, but they just want to know what the h value is, the hk. We just really care to answer the question. We just know that this is 7. That's all it was asking for. All right, I hope this helps your understanding of finding x-intercepts, finding the vertex, and vertex form. Thank you for watching.